So system of linear equations for problem solving. Okay, now there's no one surefire method of solving these because every problem is a little bit different. So the one thing you might want to do is just follow these steps. It just gives you a kind of an approach to it, to where you're not just blindly trying to pull information and solve it that way. If you kind of follow these steps, it should help you a little bit. So the first thing you want to do is you want to understand the problem. You want to know exactly what they're asking you for. Usually for these problems, the very last sentence will tell you what they're looking for, so you don't have to go through the whole thing. Okay, so understand, my eraser. Understand the problem. Either rereading the problem, or sometimes drawing a picture will help. And it doesn't have to be a detailed picture, just a little diagram showing that, what you have to put together to find your solution. This gives you a little bit of structure. Okay, so the second thing you want to do is you want to choose your variables for what you're looking for. Choose variables to represent your unknowns. Okay, now once you do that, you then translate the information that you're given into an actual equation. Okay, now your third step, you want to solve the system. And make sure your answer seems reasonable. If you're looking for x to be, 3 or 4 or 5, and it comes out to be 87, then you say, okay, maybe I messed up somewhere. So as long as it's close to what you thought it should be, you're probably on the right track. So solve the system. Make sure your answer is reasonable. Any questions so far? Okay, so we're going to apply these steps to our first example. Okay, so let's say Tom invested part of his $20,000 inheritance in a mutual fund that pays 7% interest every year, or simple interest every year. Okay. Now the rest of it, he invested into an account that pays 9% interest every year. So it was put into a certificate of deposit that pays 9% simple interest. Okay. Now at the end of 1 year, the amount of interest he made was $1,550. Then you want to find the amount he invested in the 7% and the amount in the 9%. Okay, so usually the first thing I do is look at the very last sentence, and that will give you, most of the time, your very first equation. Okay, find the amount invested at each rate. Okay, so we'll let x equals amount, invested at 7%, and we'll let y equals the amount invested at 9%. Okay, so we can use those two things to give us our first equation, because we know that he invested so much in 7% and so much at 9%. That the total amount at the very beginning they told you was $20,000. So we know that the amount he invested at 7% and the amount he invested at 9% has to equal $20,000. Okay, so we have our x plus y equals 20,000. Bring that up a little bit. There we go. Okay, so this is one of our equations. So if you want to just look at that a little later, it's that 7% plus amount at 9% equals 20,000. Okay. That's just another way of writing the same thing. Okay. Any questions on that so far? Okay, so we have our first equation. Now we have to look at our second equation. Okay, so we know that the 9% and the 7%, the amount that he invested gave a return of $1,550. Okay, so if we kind of draw our diagram underneath here, we know that 1,550 is the total amount of money he made. That means the amount at 9%, or the interest, from the 7% investment, ran out of room there, plus the interest from the 9% investment, gave us our 1,150. Oh, move that up a little bit more. Okay, so if we want to figure that out, we just have to convert the percents to decimals. And remember, to convert percents to decimals, you just move the decimal place to the left twice. So 7% become 0.07. And the 9% will become 0.09. Okay, so we know that 7% of whatever amount he invested, which we don't know, so we make that 7% of X, plus 9% of whatever he invested in the next one, so 0.09 times Y equals 1,550. Okay, so this gives us our second equation. Okay, does that make sense? Okay, so now we have both of our equations. Excuse me. That gives us our system. So you have, actually I'll start off with the second equation. So 0.07x plus 0.09y equals 1,550. And you have x plus y equals 20,000. Okay. Now the thing is, we know that if we wanted to do the substitution, all we have to do is get one of the variables by itself. So if we subtract x from both sides on your second one, you now have the system 0.07x plus 0.09y equals, oh, bring that up some, 1,550, and y equals 20,000 minus x. So now all we have to do is plug the y up here, but replace it with 20,000 minus x, and then solve for x. And continue that on the next page. Leave that up for a few more seconds. All right. Okay, so now all we have to do for that one is replace y with 20,000 minus x. So you have 0.07x plus 0.09, and instead of y, make that 20,000 minus x equals 1,550. Okay, so now we just solve for x. That's the only variable in there now. So we distribute 0.09. So you have 0.07x plus 9 times 2 is 18. Move the decimal over twice, you get 1,800 minus 0.09 times x equals 1,550. Okay. So now we just combine our like terms. Okay, so 0.07 minus 0.09 is negative 0.02. Oops, I got to combine. Plus 1,800 is 1,550. And we just subtract 1,800 from both sides. That leaves us with negative 0.02 equals negative 250. There we go. Uh-oh, forgot my x. There we go. And forgot in that one too for some odd reason. Okay, so if we divide both sides by negative 0.02, anything divided by itself is equal to 1, so those two cancel out. So that means that x is equal to 12,500, which is the amount that he invested at at 7%. Uh-oh. All right. So any questions on that so far? Okay. So now we solve for y. Remember, y is just 20,000 minus x. So we know that y is equal to 20,000 minus 12,500. So y is equal to 7,500, which is the amount invested at 9%. Okay, so any questions on that one? All right, let me bring this up a little bit. Anyone still writing? Okay. Now, probably the sort of question that would give most people headaches are mixture problems, but you really approach them the exact same way. I think you should remember those.
Yeah, I don't think I like them.
Okay, so let's say Wayne blends coffee for a local cafe. Okay, so he has to prepare 200 pounds of blended coffee beans. Uh-oh. Well, actually it is. From beans to sell for $3.95 per pound. Okay, so he wants to create a mixture of beans to sell for $3.95 a pound. Now what he's going to do, he's going to mix a high quality coffee bean and a low quality coffee bean. So you're going to mix them together and have a certain amount to sell for kind of a middle price. And so he intends to do this by blending together a high quality coffee bean that costs $4.95 per pound, and a cheaper quality that costs $2.65 a pound. Okay, so if you have it to the nearest pound, you want to find out how much of each coffee he has to have. So how much of the high quality and cheaper coffee should be blended. Bless you. Okay, so just like before, we want to go to the easiest equation first and get that out of the way. Okay, so looking at the last sentence, you want to know how much of the high quality and how much of the cheaper bean. Okay, that means we'll let X equal amount of the $4.95 bean, and we'll let Y equals the amount of $2.65 bean. Actually, instead of amount, say pounds. Maybe a little less confusing. Okay, so we know we have X number of pounds of the expensive coffee bean and Y number of pounds of the cheaper coffee bean. How many total pounds of each are we looking for?
200.
Yep, 200. So since you know that this number of pounds plus this number of pounds has to equal 200 pounds. Okay, so we have one of our equations. So if you did decide to draw a diagram, it would just be pounds of the $4.95 bean plus the pounds of $2.65 bean equal 200 pounds. Oh. Okay, so we have one of our equations. Now, using the fact that you have the $3.95, not the $3.95, the $4.95 and $2.65, we can now create our second equation. And that's where drawing the other diagram comes in handy. Okay, so we have X number of pounds of the 265, or 495, plus Y number of pounds of the 265 bean, put my dollar sign up there, equals 200 pounds of 395 bean. Okay. Now we don't know how many pounds of each, so we do know that at $4.95 we had X number of pounds. If you had 1 pound, it'd be 495 times 1, or 495 times 2. We just don't know how many. Plus, same thing with the 265. We have $2.65 times some unknown number of pounds. Okay, but we know it's going to equal 200 pounds of a bean that's $3.95 a pound. Okay, luckily here we can just go ahead and simplify that part of it. So that gives us, running out of room, 495x plus 265y equals 790, which is our other equation. Okay. So any questions so far? All right, I'll leave this up for a few more seconds. All right. Now, once you get done with, once you have your two equations, you just go ahead and put them in a system. Okay. And just like before, you want to be able to, you can use the elimination method if you want to, but that's a little more work. But if you want to use the substitution method, you just get either variable and get it by itself. And just out of habit, I usually pick the y. Okay, so we also know that if we subtract x from both sides of the equal sign, you can get the system 495x plus 265y equals 790, and y equals 200 minus x. So this way, you can just go ahead and do what we did before. Replace the y in the first equation. So replace y with 200 minus x.